Okay, in this next example, we have a system of three equations that we once again want to solve using our matrix elimination. So the first thing we do is our equations, of course, need to be in the right format. All the variables on one side, number on the other side, check that off. We got that. Variables are all in the same order in every equation, so everything lines up. So we're ready to go put it into the matrix form. And so we just go ahead and do that. So just rewriting my equation in matrix form. 1, negative 2, 3, 16. 2, 1, 1, 2. Negative 3, 3. Negative 2. And negative 22. Okay, and so at this point, we're ready to begin the elimination process. So remember, we need everything below the main diagonal to become a 0. So we start with the first column. We're going to worry about the 2 and the negative 3 first. We'll come back to this other spot later. So we need to set up row operations to eliminate the 2x actually, and the minus 3x out of that equation and come up with our new equations. So there's different ways that can be done. Since I have a 1x in this top row, I'm going to make use of that, and that's what I'm going to use. You could do other things, but I'm going to go ahead here and say minus 2 times the first row plus the second row. All right, and if I did that, minus 2 plus 2 will be 0, and it'll eliminate. And I'll carry that through in a moment. For the third row, I'm just going to do 3 times the first row, and then add that onto the third row. Okay. And so again, that would eliminate the minus 3 as well for the third row. So rewriting my first row down, and then we just go through for the second row, perform our arithmetic. Minus 2 row 1 plus row 2. So minus 2 times 1 plus 2. Of course, just like we want, that's going to be 0. And then we continue. Minus 2 times minus 2 will be 4 plus 1. We'll make that 5. And we continue. Minus 2 times 3 is minus 6 plus 1. We'll actually make that minus 5. And then we have finally minus 2 times 16 will be a negative 32 plus 2 will make that one negative 30. Now if you wanted to, you could go ahead and divide everything in this row by 5 since 5 goes into it. A lot of textbooks are kind of real prime on doing that. Extra stuff, but I just avoid it. And we continue here with row 3. So we're taking 3 times the first row plus the third row. Of course, 3 times 1 will be 3 plus 3. We'll zero it out just like we want it. And then we continue. Minus 3 times minus 2 will be minus 6. Plus 3 will be minus 3. 3 times 3 will be 9. Plus minus 2 will make that 7. And then finally, 3 times 16 is 32. I'm sorry, 3 times 16 is 48. And the negative 22 gives us a positive 26. Positive 26. So now we've taken our matrix and we've eliminated the 2x's out of the other two equations. Now that means to continue now, we need to get rid of this last thing here in our diagonal, this last place, and that's the minus 3. Now unfortunately we can't use row 1 anymore because using it again will just undo the zeroing out that we've already done. So we're kind of reduced now to just looking at these rows 2 and 3. And unfortunately there's nothing nice to multiply 5 by to get 3 or 3 by to get 5. So we can just go in and say 3 row 2 plus 5 row 3. All right, because 3 times 5 will be 15. 5 times 3 will be negative 15, and they will eliminate. So that's what we need to do here. So I'll go ahead and write down rows 1 and 2 again, because they're not going to change this time. And then we carry through our arithmetic. 3 times 5 is 15. 5 and negative 3 is negative 15. So, of course, those 0 out just like we want. Of course, 0 and 0 is also 0. And then we do the arithmetic here. 3 times minus 5 will be minus 15. 5 times 7 will be 35. Minus 15 and 35 will be 20. And then 3 times minus 30 will be negative 90. 5 times 26 will be 130. Negative 90 and 130 gives us a positive 40. And so now we've put our matrix into its reduced form. We've zeroed everything below the main diagonal out. So now we're ready to solve. So we start in the bottom row. And we have 20z equals 40. And we can divide both sides by 2, and we get z equals 2. And now once we know z, we can go up to the second row. Now I'm going to cut a little writing down here. This is 5y minus 5z equals negative 30. So when I write that down, I'm going to write it down as 5y, and then minus 5 times z will be minus 10 equals negative 30. And then we can solve for y, bring the 10 over, get 5y equals 20, 5y equals negative 20, sorry, and then divide both sides by 5, and we get y equals negative 4. So now we know y is negative 4, we know z is 2, there's one last piece remaining, and that is to find x. So we're going to go up here, x minus 2y plus 3z equals 16. So I'm going to write that down as x. Since y is negative 4, minus 2 times negative 4, we'll make that plus 8. And 3 times z would be plus 6 equals 16. So we have x plus 14 equals 16. So of course, x equals 2. And now we've solved our system of equations here.